Okay, now coming to 88 number question. It is given that to find the radius of a neutron. Okay, and there are four options. In the first option, it is given that the distance r equal to RD, where the solution falls to 1 by 2. Okay, 50-50% of the value when the value of this wave function when it was at r equal to 0. Okay, and in the option B, it is given that root over of m e d by s cut, and option C, 2 s cut by m root over of m e d. Okay, if you see closely these two options, sorry, the two options, they are inverse of each other. Okay, you see here s cut is in the denominator, here in the option C the s cut in the numerator, and this term is in the numerator, this term is in the denominator. Okay, and in option D, it is given that the distance r equal to rt, where the wave solution falls to 1 by eth of its value at r equal to 0. Okay, so to find the solution, you see this is the wave function, this is the potential, rectangular potential level. We have just solved this question in the 87 hour question. Okay, there in the solution we are getting two wave function in the region 1. This is region 1. Okay, in this region we are getting the solution as a sinusoidal. This is the sinusoidal kind of solution. Okay, it is increasing sinusoidally, and that means from 0 to p, the dominance part of this wave function is sin kappa 1, kappa 1 r. Okay, and after b, the dominancy of this exponential decaying exponential term is increasing. Okay, and combining both the sin kappa 1 r and e to the power gamma r is the wave function of this neutron. Okay, now you see the you take this wave function psi 2, let's take is u2. Okay, that means wave function in the second region. Okay, this is d e to the power minus gamma r. Okay, now what you have to find the radius of this neutron, what you have to do, we have to make the r equal to 1 by gamma times. Okay, so if you make your r equal to 1 by gamma times, then if you put this 1 by gamma here in the place of r in this wave function, okay, then you will get a what you will get a u1 u22, that means wave function in the region 2 is equal to d by e. Okay, because there is minus sign here, so minus gamma into 1 by gamma, so e to the power minus 1, that means d by e. Okay, this you will get this. Okay, so this is a definition of a radius of the neutron, or we also know that the value of this gamma while deriving the equation of a wave function in the second region, we know that this value is gamma equal to root over of capital M energy of a neutron divided by s square, and if you take this out, this s cut, then you will get only s cut in the denominator. Okay, if you are not recognizing, you see this, while solving the second region wave function, we have got this value, the value of gamma is root over of m ed by s square. Okay, so that expression is here. So as we have made that r equal to 1 minus gamma, then what will be the value of gamma in this expression? It will just flip, reverse. Okay, so m ed will get this only. Okay, but in the option, if you see, there is no such value. Okay, there is no such value. This is some kind of relative, but there is 2 is multiplied here. So option C is not correct. Okay, and if option C is not correct, option B is also not correct, because it is in the reverse of the expression, because that means the dimension of this radius is this option B. You look option B. The dimension of option B is in 1 by meter inverse, like something, or meter inverse, centimeter inverse, nanometer inverse, femtometer inverse, like this. But the radius cannot be in the uh, inverse term, inverse meter term, centimeter inverse, not. Okay, so option B and option C are not correct. Now you see option A. Option C, it is given that the distance r equal to rd, where the wave solution falls to 1 by 2. No, this is not correct, because we just have seen that to find the radius, we have to take r equal to 1 by gamma. Okay, so if you take r equal to 1 by gamma, then your wave function is becoming how much? Your wave function is becoming how much? U double 2 equal to d by e. That means whatever value of d, that that value divided by e, and the value of e is almost 3, you can say. So that means 1 by third part. It is almost 1 by third, because the value of e is you can say 2 point the value of e is 2.73. It's almost 3. Okay, that means if this term is 0. Almost 0.3 of a d, whatever value of this d. Okay, so what you have to find, we have to take the 1 by third of this wave function, and this wave function is, if we extend it, you see, in this region 1, the dominancy of a sin kr is present. So that's why you cannot get the effect of e to the power minus gamma in this 0 to b region. Okay, because here the sin kr is playing the role effectively, and there is you cannot get the role of e to the power minus gamma, but the effect of gamma also present here, but that effect is very negligible. Okay, so now if you extend this part, okay, like this, if you extend this part, I am extending this e to the power minus gamma r. Okay, so it will meet somewhere. Okay, and this value is from 0 to this value is the value of this u double 1 at r equal to 0. Okay, this is the r equal to 0. Okay, so at r equal to 0, this is the value of the second wave function. Okay, but due to the sine present, the sine wave is present, so as the sine wave is 0 at r equal to 0, so that's why the total value is the wave function value is 0 at the origin. Okay, so but if you extend this part, it will meet somewhere point, like in the, it will the maximum value, like d. You see, if you put where the you see this part, if you put no this part, you see I am, here I have written c, so you keep it d. Okay, for example, you take it d. So when you put r equal to 0, you will get e to the power 0. So e to the power 0 equal to 1. So you will get the maximum value at r equal to 0. C is the maximum value. Okay, why? Because r cannot be negative. R is from 0 to infinity. R cannot be negative. So this is the maximum value. Okay, take it C or D, for example. So at r equal to 0, this is the maximum. But to find the radius, we have to take how much part? 1/3 part. Okay, 1/3 part. So if you take, you will get this. Okay, this will meet here, and this is the radius of a neutron. Okay, this is the 1/3 part, because we are taking 1 by e of this d, whole d. This is the value of d from this to this, and you take 1 by third. Okay, let us suppose this is 1 by third. So this is 1 by third, let's suppose, and you meet here. This point is meeting here, and you just put a perpendicular on the r axis, and you will get the value of rd. Okay. Okay, so come to 89 number question. It is given that the nucleus, for this nucleus lithium Li7, the ground state spin parity are, okay, so we have to find the spin parity of the ground state of the lithium Li7. Okay, so for lithium the atomic number is Z is equal to 3. Okay, so hydrogen, helium and lithium, so it is in the third number in the periodic table. Okay, so for this lithium, L equal to proton number equal to 3, and as the atomic number is 7, so that means there are how many number of neutron? 4 number of neutrons are present here in the case of Li7. Okay, so apply the cell model. Okay, so if you apply the cell model, then you will get the solution like this. You see, for Li7 there are 3 proton and 4 neutrons. Apply the cell model. The ground state is 1s1 by 2. The second state is the first excited state of the cell model is 1s 1p3 by 2. Then the other one is the upper one is 1p1 by 2. Okay, so arrange the nucleons separately for proton and neutron. So 2 protons are present here, 2 neutrons are present here in the 1s1 by 2 state, and as there are only 1 proton, okay, so only 1 proton is present in 1p3 by 2, and 2 neutron are present in the 1p3 by 2. Okay, so if you see the proton is paired, so once they are paired, that means the contribution of a spin parity for this neutron is spin equal to 0 and parity equal to 0 plus. Okay, so that means they are not playing any role in the spin parity contribution. Okay, so now proton will play in to affect the spin of the lithium nucleus. Okay, so for this outer unpaired proton, the effect of a spin parity will take place. Okay, that means this proton will give the spin and parity of this nucleus, lithium nucleus. Okay, so as it is singly present in the 1p3 by 2, that means the nucleus has spin 3 by 2. Spin means the total angular momentum. Okay, orbital angular momentum addition with a spin angular momentum, that combination is known as spin. Okay, in the nuclear physics. Okay, so J equal to 3 by 2. So what is the parity? Parity is minus 1 to the power L, and L is as it is present in the 2p. So you see the term p, the term p means L equal to 1. So you put here, so minus 1 to the power L, you will get negative 1. That means odd parity. So the spin parity is 3 by 2 negative. Okay, so option C is the correct one. Okay.